we just go ahead to balance the charges. Now to balance charges, like we did in the previous example, 2 minus 14 hydrogen ions, 2 chromium dot, 7 moles of water. Now to balance the charges, we have to add electrons. So the question now is, where do we add electrons? To know where to add our electrons, we simply have to count or calculate the number of charges we have at the right side and at the left. So how many charges do we have at the right hand side? We have 2 times 3. There are 3 charges there for chromium, but because chromium is 2 atoms, so we are going to multiply it by 2. So we have 2 times 3 plus, which gives us 6 plus 6. So it means we have 6 positive charges at the right hand side. Water has no charge. So let's go to the left hand side. How many charges do we have? We have 14 charges, 14 positive charges here, and 2 negative charges. So when we add 2 negative charges and 14 positive charges, what will be our net charge? The net charge is going to be 12 positive charges. So when we cancel out 2 negative charges against 2 positive charges, we have 12 positive charges left. So it means at the left hand side we have 12 positive charges, but at the right hand side we have 6 positive charges. So where do we add our electrons? Electrons are negatively charged. So where do we add electrons that will make these charges to be balanced? It means we will have to add electrons at the left hand side. And how many electrons do we add? It means we'll have to add 6 electrons at the left hand side. So when we add 6 electrons at the left hand side, 6 electrons which are negatively charged, we cancel 6 positive charges here at the 12 positive charge. So we'll be left with a grand net of 6 positive charges. So it balances up with these 6 positive charges at the right hand side. So this is actually how to balance our charges. But first of all, we need to know where to balance, where to add the electrons. Now, in a nutshell, we just have to understand that in a reduction half cell, electrons should be added at the left hand side. That is just what I want us to know now in a nutshell. So in conclusion, reduction half cell will have electrons added at the left hand side, while oxidation half cell will have the electrons added at the right hand side. So always use that as a point to remember. Take it as the yardstick to remember that if I am to add electrons to a reduction half cell, then the electrons must be added at the left hand side, but electrons will be added at the right hand side if it is the oxidation half cell. And that tells us that when a species gains electrons, it is reduction, but when a species loses electron, it is oxidation. That is just what it tells us. So, and that is how we've defined our oxidation. Oxidation is loss of electrons, but reduction is gain of electrons. So you can see A is gaining electron. So when A gains electron, it becomes just a neutral A. But when B loses electron, you can see B has lost electron. It becomes what? Positively charged. Depending on the number of electrons. If it loses 2 electrons, it will become 2 plus. If it loses 3 electrons, it becomes 3 plus. So that is actually how it goes. So always know that for oxidation half cell, electron is added at the right hand side. But for reduction half cell, electron should be added at the left hand side. That is just what we should know. Okay, now we have seen where to add our electrons. So we have to proceed in doing so. But before we do so, let us also look at the oxidation half cell, ion 2 to ion 3. Where do we add our electron? Just as we have explained, for oxidation half cells, the electron should be added at the right-hand side. So how many electrons are we going to add here? We are going to add 2 electrons here. And 1 electron, I beg your pardon. It means we're going to add 1 electron. We're simply going to add 1 electron at the oxidation half cell. That is how it's going to be. So let's proceed now to adding our electrons. Since we've known the number of electrons to add at the right-hand side and at the left-hand side of these reactions. So we now proceed. Let's carefully do this. So now we add our electron, 1 electron for the oxidation half cell, and for our reduction half cell, we are going to add 6 electrons. We've added 6 electrons as our reduction half cell. So let's proceed. So to proceed now, we simply go to our next step, and the next step is to balance or equate the charges. So since we added 1 electron to the oxidation half cell, let's not forget this is oxidation half cell and this is our reduction half cell. So since we added 1 electron to the oxidation half cell, it means we'll have to multiply the reduction half cell with 1. Everything at the reduction half cell will multiply it with 1. And since we added 6 electrons at the reduction half cell, we'll use 6 and multiply every species at the oxidation half cell. So let's go ahead to do that now. So we're going to have 1 times everything for the reduction half cell. So for the reduction half cell, we are trying to equate the charges now. For the reduction half cell, we have Cr2O7, 2 minus, plus 14H plus, and that gives us 2R3 plus and 7 water. And then for the other one, we have 6 times, and 6 times what? 6 times ion 2 going to ion 3, and then our electron. So that is what we have. Okay, so sorry, we have a little mistake over there. We have omitted our, okay, maybe we'll just have to add it up here. So let's just do that. We have this 1 times. So what we need to do is we omitted the 6 electrons we added for the reduction half cell. So we're just going to repeat that so that we have that correct. This is hydrogen plus. So let's just carefully take this away and add up our 6 electrons. I told you electrons can be added either before the Cr2O7 or after it. Anywhere we add the electron is fine. So we just have to add our 6 electrons here, and then we have our 2 chromium 3 plus 7 water. I want to believe there is no challenge here. It is still the same thing. Don't forget we added 6 electrons from step 6. So this is step 6. We added 6 electrons there. So we, instead of bringing it before Cr2O7, I just brought it after the 14H plus. It's the same thing. Wherever you place your 6 electrons or 5 electrons or 10 electrons, as the case may be, whatever, it is the same thing, whether at the back or within the equation, at the middle of the equation, it is still the same. There is no challenge with that. So let's write out what this equation should be now. So this is our step 7, don't forget. This is step 7. So 1 times Cr2O7 is Cr2O7, 2 minus. 1 times 14H plus is 14H plus. 1 times 6 electrons is 6 electrons. 1 times 2 Cr3 plus is 2 Cr3 plus. Then 1 times 7 moles of water is 7 moles of water. In the case of oxidation half cell, 6 times Fe2 plus is 6 Fe2 plus. 6 times Fe3 plus is 6 Fe3 plus. 6 times 1 electron is 6 electrons. So we have done the step 7. So we'll proceed to step 8, but before we do step 8, we'll have to cancel out what is common. And what is common is 6 electrons, 6 electrons is common. So now we sum it up in step 8. So step 8 says we sum up the things, the reactants, and then the products. So we have to sum them up. So let's proceed to step 8. So in step 8, this is the 8th step, we have to sum up what we have. So looking at the equation, we have Cr, let's erase that a little. So we have Cr2O7, 2 minus, plus 14H plus. Our electron has gone, so the next thing is 6Fe2 plus. Don't forget we are adding the reactants first. That is reactants for the reduction half cell and the oxidation half cell. We will add all the reactants first, then followed by the products. So we have 2 Cr3 plus 7 molecules of water, then plus 6 Fe3 plus. This is what we have. So with this, we have successfully balanced the equation in an acidic medium. This is an acidic medium. But the question says in a basic medium. In a basic medium. So what do? We'll go to step 9. Step 9 says we now add OH. We have to add OH to this equation. So we are adding OH on both sides of the equation. So let's proceed now. Step 9, because it is in a basic medium. So we have Cr2O7, 2 minus, plus 14H plus, plus 6 Fe2 plus, plus our OH. Since we are adding OH, we have to add the exact quantity or number of H plus that is already there, so that the OH that is coming in neutralizes the H plus that is there. That is actually what we ought to do. So it's as simple as that. So we have to go ahead now to add our OH. So we have 14 OH. Since we already have 14H plus, we have to add 14 OH. So in adding our 14 OH, this gives us 2 Cr3 plus, plus 7 H2O, plus 6 Fe3 plus, plus 14 OH minus. So this is actually what it should be. Now if we are to rearrange the equation very well, since we have H, 14H and 14 OH, this, whenever H and OH comes together, they actually cancel out each other by forming H2O. So that is actually how the reaction goes. So whenever OH and H comes together, they actually leads to the formation of water, H2O. So since we have 14 OH and 14 H plus, then it means they will have to cancel out each other. And once that is done, if they cancel out each other, we need to rewrite the product that they give. And what is the product? It is water. The product is automatically water. So 14 H plus and 14 OH will give us water. That is actually what it gives us. So let's rewrite that and know how many water molecules it's going to give us. So now we have Cr2O7, 2 minus, plus, let's write our 6Fe first, 6Fe2 plus, then plus, when we have 14H against 14OH, it's going to give us H2O, but how many H2O is that? Now looking at it, we have 14 hydrogen and 14 OH. This 14 OH means we have 14 oxygen and 14 hydrogen too. So in a nutshell, we have 14 plus 14 hydrogens. That is 28 hydrogens. So we simply need to put 14 here so that we have 14 times 2. It still gives us 28. But 14 times 1 oxygen gives us 14 oxygen, just as we have there. So this tells us that, it tells us simply that this is 14 times 1 oxygen. That's 14 oxygen. 14 times 1 hydrogen is 14 hydrogens. And here we also have 14 hydrogen atoms. So 14 hydrogen atoms and 14 hydrogen atom here is 28 hydrogens. But 14 times 1 oxygen is 14 oxygen. So it means we are going to simply have 14 moles of H2O. So it gives, so that the equation will be balanced. So the next, now we go over to the next side. The product side is now going to be 2Cr3 plus and 7 moles of water plus 6Fe3 plus 14 OH minus. There is no H at the right hand side to combine with that 14 OH minus, so we have to leave it that way. Now look at what we have here. Looking at what we have here, it tells us simply that there are 14 molecules of water at the left hand side, but we have 7 molecules of water at the right hand side, so they can cancel out each other. So 7 moles of water can take away 7 moles of water from these 14 moles, such that we now have our equation now to be Cr2O7 2 minus plus 6Fe2 plus 7 moles of water has been taken away from this 14 moles of water, so we are left with 7 moles of water. Then we have 2Cr3 plus 7 moles of water has already gone away, and we'll be left with 6Fe3 plus 14 OH minus. And this is the final answer for that equation. So this is how to balance redox reactions in either acidic medium or basic medium. So we have seen the first example is only in acidic medium. And this second example, we can see that our balancing in acidic medium stopped at the step 8. Then from step 8, we proceeded to looking at how to balance it in step 9. And we said that to balance it in step 9 is simply to add OH on both sides of the equation. And when we add OH, when OH meets H plus, it's simply going to form water. So we just balanced it with the appropriate number of water, and then water cancelled out each other at the left and the right hand side, and we have what is left as the equation for that reaction in a basic medium. So this is how to balance redox reactions in basic medium. So with that, we'll go to our next example, example 3.